Harijana, thank you so much for joining us on the show today. I wanted to ask you a little bit about your journey. Tell us about your life and how you reached this point of becoming a roboticist that's so well respected around the world.
My father was a civil engineer, and I admired him. I adored him, and I really wanted to be like him. But I think because of him, and I suppose I was gifted enough to be interested in mathematics and physical sciences. So from early childhood, I remember I was always very good in math and, and interested in physical devices, which was not that common for girls in those days. Remember, we are talking about 1940s or so. But any case, so then in high school, in gymnasium, again, I excelled in mathematics. And that brought me to the university to electrical engineering department because uh, that was kind of the most mathematical. Initially, I wanted to really study mathematics, but for various political reasons, I wasn't allowed to, so I went to study electrical engineering. And that kind of brought me to my career, which really, and in those days, I was always interested in fundamentals. Um, of course, as an engineer, you also have to look at it. What is it good for? What is it useful? But my primary drive was to understand how it works, why it works, and when it will fail. And so that brought me through an academic life was a kind of natural place where you were allowed to do that. It typically you didn't go to academia because of money. If you really were interested in money, you went to industry.
Hasn't changed.
No, but if you were interested in having a certain freedom to investigate and ask some hard questions, you went to academia, and so that brought me to university as an assistant professor, and then I had the opportunity in 1967 to come to US. So I jumped on that opportunity. I came to Stanford, and that was just a tremendous pleasure and eye-opener and opportunities to do things that I was interested and where everybody in the lab was interested in. It was really the birth of what's called today artificial intelligence, but in those days it was a much broader agenda than today. Today is kind of focused on the data and machine learning. When I started in 1967, artificial intelligence was really understanding. The emphasis is on understanding the mechanisms of how we perceive, how we carry out action, how we connect perception to movement, action, and also reasoning. There was a tremendous emphasis on what do you, when you extract data through your sensors, how do you minimize the representation? What is invariant in that information? Those were the questions that intrigued me, and I have been working on them ever since.
When did you feel you were a roboticist? Did you was there an active was there an action of going into robotics, or did what you were doing become robotics? How did you position that?
Well, Sabine, when you are in the middle of this curiosity-driven work, you don't worry about labels, whether they call you computer vision person or roboticist, you don't care. Really are interested in understanding what makes people in some ways as a behavior. Why do they behave as they do behave? And can you make those behaviors more quantified so that you can then take this quantified model and make and use the machines to duplicate those behaviors. So I don't think that the label of robotics is, or I mean, I held position in the University of Pennsylvania. I was a professor of computer science. So, but so nobody cared about the labels. Do you see what I'm saying? Yeah.
I do. And you never know the labels until it's happened
Right.
to you. So
Right.
you put the
Right.
labels after the fact. What are some of your proudest robotics works? Tell us a bit about the foundational moments in robotics that you helped to contribute to.
Yes. Well, I think my most productive years were in the 80s and 90s at the University of Pennsylvania. And we really explored this symbiosis between different modalities. So I looked at tactile contact sensing with the vision, which is more geometry. I mean, contact sensing also has geometric representations, but it's a much more local and it's more physical, while the visual representations and perception are much more grounded in geometry and optics and those fields. But I was always interested, how do they complement each other? So I had several students who looked at, how do you control the information acquisition? Where do you look? How do you look? Why do you take this information as opposed to that? How is it goal-driven or explore? How do you explore the environment when you come to an unknown room? Where do you look? So those were the questions that I was trying to answer. Then later on, with respect to this representation issue, which is really given the perceptual information through your cameras and through your contact sensing, and maybe the robot position sensing, is how do you is this all what you really want to store, or what you want to, we didn't call it learning, but it's in principle, what is the information you want to store so that it's useful to you later on for recognizing environment, objects, and so forth. And so I realized that vision, and at that time the studies were much more static. And if there was dynamics, it was, the things move to recognize how they move. But I felt that there was another component to the object, the semantics of the object, and that was functionality. What is cuttable? What is liftable? What is graspable? What does it mean? What does it mean, a chair? Is it sort of just the geometry that many people saw that was enough? I always felt that in order to really identify that this is chair, you have to test if you can sit on it, because you can have a paper chair and obviously you will not be able to sit on it. So, so I had two students who investigated this, and I think we were the first one who investigated this in a formal way, that we designed an algorithm, a procedure. How do you test this functionality? And it's interesting, when we did that in the late 80s or 90s, it was too early. But that's what academics should be, too early. We should be looking at the problems that are 10 years ahead of you and not just what can we do today or next year or so. I send you those papers because I think we were the first one, and hopefully people will come back to these older papers and recognize that we really were pioneers in this understanding how you validate, test the concept of cutting or
I just wanted to
piercing.
show one of these papers.
Yeah,
So
good,
here
good.
I have one of these papers, which is called Segmentation via Manipulation, which is a
Yes,
paper from
yes,
1988. There's another one that's called Interactive Recognition and Representation and Functionality from
yes,
1995. And you're right, these are titles that we could see now, actually, that we can see
yes,
come back into fashion
yes,
because it's timely again. We're trying to figure out how robots can make sense of their world.
that's
What
right.
has changed? What has changed now
Oh,
that means
wonderful, wonderful question, because it's really close to my heart. What has changed? And this is, I think, the message to the young people. There is a worthwhile for the young people to look at some older papers, because many of the new ideas, what's called the new ideas, have been around. We recognize them. What we didn't have the compute power, the fast compute power. We didn't have the memory to store all the information. And we did not have the good sensors. Today, you can buy a very inexpensive three-dimensional cameras. You can buy robots for, 20,000. In my days, you bought a robot for 150,000. That was the cheapest robot, okay? So a lot of the technological devices that can facilitate testing these ideas are now available.
so those
But of
ideas,
course, also because of this, because of sensors and people collect much more data, so a lot of the statistical methods that now have been elevated, to high acceptance are facilitated by the fact that you can collect a lot of data and you can store it, and students can play with it and so forth. So a lot of the technological advances, but I think it behooves the junior generation is to look at the old ideas, the concepts, all right, and then see how far the theoretical aspects of those concepts can be pushed further, but they also can now validate, as good engineers should, these old conceptual theories.
and I think we're all guilty of that, of not looking past the
Well,
5,
I
10
tell you,
years from now.
Sabine, I have a hypothesis why we are guilty, and the guilt comes from that there, at least the younger people feel pressure, publish, publish, publish.
Mm-hmm.
And I think I never felt that.
Mm-hmm.
You know.
And novelty as well. You feel pressured to have novelty to publish.
Right,
You
right,
forget that this novelty must have
right,
been there
right.
20,
But
30 years ago.
and this pressure of publish, publish, publish
Mm-hmm.
leads to sort of not careful designed experiments, because carefully designed experiments, whether they are with robots or with people and robots, take time. You really take time. And so you can't have a paper every 3 months. And so to me, that's a pity, because in the long run, the question is how much of this publish, publish, publish every 3 months will be able to sustain and remain as a valid result.
And yet you keep going. You send me a paper from 2017, a presentation from Berkeley from 2020. What are you
Yes.
interested in today?
Well, okay, so it's really more or less not my work, but it's my students' work. I mean, let's face it. I mean, you have to be fair where where one should be there. So, so I kind of try to inspire my students to ask some questions that the physics of, for example, one student, Caroline Chan, is studying that if, what does it mean pouring? When you have either liquid or you have sugar, granular sugar, can you measure the granularity and the viscosity between the granules, which is that there are physical models for that. But what she can do with these, she can estimate, which is called the systems identification. Not very much in vogue anymore, but but anyway, she's doing it. And then use those parameters that she identifies for controlling the pouring, or the pouring, or even for that matter, steering. How hard you really have to steer depending on the viscosity. So that's her work. And so I think my students really, so they are very kind. They put my name on the paper, but it's actually their work. And, I just keep it.
Yeah. It's as you say, it takes time to do proper research.
Yes.
It's challenging. What are some of the challenges you've faced on this robotics journey?
Well, the type of work that I have done, the functionality, the segmentation with, non-visual segmentation, but with the robotic, are what you would call systems type of work. So you have to build the visual system, you have to build force feedback system, and then you have to build the control. And those are the components of but you have to put them all together to work. And you have to think about, how much data do you want to process so that you can do things in real time. That's another constraint. Real time, don't have time to, I take a picture and now I sit there and think about it, and then I move, and then again I take a picture and think about it. That doesn't work that way.
Pulls in different directions.
Yeah. So you have to really think about what algorithms you want to use in order to deliver it in real time. And again, I will give credit to our hardware colleagues and all our architecture people, and who facilitate us to build these systems. And then you can do some interesting goal. You can study some interesting actions and goals. So, but still, because you have these different components, you have to understand them, you have to plan them, you have to calibrate them. So that takes time.
It's interesting.
And you have to make sure that they mesh together.
It's interesting because the challenge very often is the integration. It's putting it all together, and yet that doesn't get a lot of credit. You don't necessarily write the papers about the integration.
And actually, there are some beautiful mathematical tools for this integration. I use discrete event systems in control. There are some Markov processes you can use for control. So there are some, you have the distributed system as a control, and synchronization comes into it. So the students who work on these kind of things, they are forced to really learn a lot of different aspects of the problem. And that's another discouraging component, because it's much easier if you just work in machine learning. You take some data and you do some statistics and you can do some optimization, and boom, you have the results. You have a paper, right? But if you really are dealing with these physical components, then you have an interval in which it works. But if these intervals don't overlap properly, you are out of luck.
Yeah, definitely. What does a day in your life look like? Can you walk us through a day? And you can pick before COVID or currently today, up to you.
Well, um, I hate to admit, but I am a workaholic.
Mm. Mm-hmm.
And I spend a lot of my time, um, reading old papers and new papers just to understand. Also, I am, as I get older, um, I need to write down a lot of materials because my short-term memory is not as good as it used to be. So I need to remember, I need to refresh my memory. But then, sort of, as I go through these materials, I am thinking about, which parts I agree with, what I don't agree with, and try to understand, is it because I don't understand fully the paper, what they are saying, or is there really somewhere a hole? So if you ask me, how is my day? So I get up around 8 o'clock and then just have breakfast and then I work a little bit and then I have lunch, the usual. Before Corona, I would go to the office, of course, and talk to the students quite a bit. Now, the interaction with my students is only through Zoom, and I retired officially from teaching starting last July. So I'm not teaching until then. I had a class every week, so that took some time of me. But so now I don't have that. I am just, doing my thinking, research, reading. But I will tell you that before the corona, I also like to cook. So, it's as a good experimentalist, it's
And
sort
not
of,
after Corona, because Corona, for many of us, has given us more time to cook. So we picked up cooking.
well, but the problem is, here is the problem. I don't cook now very much because I just live by myself.
Mm-hmm.
Before that, I would entertain. I would have parties for the students. I would have parties for some colleagues. So I had a good reason to cook.
Yeah.
Now I don't have very much
Oh, that
reason.
makes a lot of sense. Yeah. I
Yeah.
would love
And
to.
also remember, being as old as I am, I have to really watch how much I put into myself. Otherwise, I
You make
can
a big
grow like this.
cake.
Yeah, and I don't want to do that.
I've
So.
fallen into that trap as well. I would love to read the notes that you're taking about all the papers that you're reading. You must have such a beautiful map somehow of the literature, novel and the older literature that we.
Well, I, and maybe this is a little bit my background from Czechoslovakia. When I was young, Sabine, the idea was that you are not just a technician, you are an intellectual. And that sort of is very much in the old European sort of sentiment. So, of course, in these days, it's very hard to be really, well read. My mother, she always was extremely well read, and she knew all the current um, literature, the people who wrote books and so forth. I have to limit myself. Nevertheless, if you work in robotics and especially human robot interaction, you cannot avoid to look at what the psychologists have to say, what the neurologists have to say, at least some of them. And sometimes, well, and of course, I read quite a bit the old mathematicians, who were really science philosophers, who thought broadly about many of the issues. Galileo, if you think about it, and thinking very broadly. And so I try to read some of these papers, but but because the field is all the psychology, sociology, economics, wherever the computer kind of technology touches up is so much bigger. So you have to be careful not to get lost because because I am interested in depths, but if you go too breadth, then you do it at the expense of depths, and I don't want to do that. So I'm worried about those things.
What would you tell your younger self about a career in AI, robotics, whatever it was called then?
If I would be young today, what would I
What would you tell yourself?
Learn as much mathematics as you can, because it's much harder to do that when you are older. If you are young, your neurons are much more flexible and the connections are made, and your memory. And in mathematics, interestingly enough, I am not sure that people fully realize that, but in mathematics, you really can benefit very much if you have good memory recall, because a lot of the derivations are from this to that to that. They are all connected. And if you can remember the origin of this, then you can very easily understand the theorem here as a derivation from there. But for that, you really is useful. And in my career, as I met some very successful people in this business, and they all had very exceptionally good memory.
Interesting, I didn't know that. Makes sense. It makes a lot of sense.
Yes.
What do you think is the next frontier in robotics? Where do you think robotics is going from now?
Wow, that's a hard question. I really honestly, well, let me speculate a little bit. So, in a short run, seems to be that that this interface, how you interface with human activity. For example, I give you an example. Let's suppose an application for elderly people, which I have thought quite a bit about. It's as you get older, a lot of your functionalities get reduced or completely shut off. Joints are harder to move, your memory is shorter, and so overall your behavior capacity is limited. So in that sense, seems to me that the robotic technology can, by recognizing what are these facilities that you are missing, can supplement them. So look, I use glasses because my eyesight is not, I have a hearing aid, okay, here, because my hearing is not so great. So I think there are places where robotics can be extremely useful. And, some people going much further, they talk about implants into the brain, and there are implants for diabetes, to checking your glucose, and so there are a lot of useful things. Now, this is all around the utilities of the technology for humankind. Where are the deeper issues is, to me, the deeper issues are, and this corona is showing it, is in this social interaction. How many people, how many people want to be together physically? And you can take this even to the animal world, you know. You have monkeys that kind of, there is a family, you have elephants, there are families, but then you have some loners, like tigers. They by and large, they live by themselves. So there is a very interesting sociological problem of this grouping, and what is the utility of the grouping. And then from there, you can start to study is, you know, this, that there is this issue of communication. We are reasonably okay in connecting perception with action, individual behavior. But we are not okay in when you add to the perception action communication. You know, what do you communicate? How much do you communicate? What kind of delays do you really can afford in order to really get the message? Okay. And that, you know, is sort of reaching to sociology of, you know, how can we model this interaction?
Those are all things we take.
That's to me is,
Yeah, those are
yeah,
all
because think about it, it's not only modeling how people communicate, but then you can start to ask, you know, if you insert into this group robotic system, how will that enhance or or delay or whatever? Now, this is really leading towards what people are starting to talk today. You know, what should be the control of these groups? Is it a democracy or more the authoritarian kind of regimes, which are more effective and and viable? You know, there are some people who claim that the authoritarian, which is a hierarchical top-down, and you know, China is a good example, will say that is much more effective in delivering services to people, you know, than in the democracy, which is a distributed, and you have to come up with some kind of consensus and so forth and so on. So those are the questions that seems to me are upcoming.
That's fascinating. And it's fascinating how developing robots always brings us somehow to society and how we develop as humans and as a society.
Right.
There's always that parallel between the two worlds.
Right.
Um, Thank you so much. That was incredibly inspiring, and it was really wonderful to have you
Good.
on the show.